Hello Math 152 students. In this video we'll take a look at part 2 and finish up our comments on the binomial distribution and the normal approximation. So we just looked at our first example and we saw that the n times p times 1 minus p was small, 1.02, not big enough to approximate this with a normal curve. Makes sense, it doesn't look normal. Now for our next example, we have a curve we have a histogram that is from a binomial distribution with an n of 8 and a probability of 0.5. So if we input that into our formula, we can do n times p times 1 minus p. In this case, 8 times 0.5 times 1 minus 0.5. And in this case, if you wanted to simplify, this just becomes 8 times 0.5 times 0.5. Most of the time you're going to want to use your calculator. Drop this in and you'll get 2. So in this case, our condition is not met. And this one is a little bit tricky because our curve looks approximately normal, but in fact, we just don't have enough data for this to be smooth and for our normal approximation to be very accurate. So in this case, our condition was not met. Our n times p times 1 minus p was 2, not bigger than 10, and we would not want to use a normal curve to approximate this histogram. Let's look at a third example. In our third example, we have a much larger n value. And notice when I look at this curve, I have something that looks like it's normally distributed. Now, because for a binomial, you could have no successes, 0 successes all the way over here, it looks like our histogram is pulled to the right. But if I just focus on kind of this portion, that looks like you could approximate it with a normal curve. Let's go ahead and plug into our formula our n times p times 1 minus p, see what we get. So let's see, we had 70, I believe, there, times 0.8, times 1 minus 0.8. Okay. So just double check we've got everything in there. And then in this case, I believe we get a little bit over 11. So plug that into our calculator. And I'm getting 11.2. So in this scenario, this value is above 10. We've met the condition of being greater than 10, and we could use a normal curve. Notice that this histogram is a lot smoother, a lot less chunky, and we would be able to make a pretty good approximation. So in this case, we'll stop here. What I do want to point out is that if you do know you have a normal distribution, you have formulas for mean and standard deviation that we looked at in Chapter 6. In practice, in future chapters, we're going to be looking at proportions, and we'll actually modify these formulas some when we're looking at proportions and not just number of successes. So I'm not going to focus too heavily on computing these because all we really want to do is make a yes or no decision in scenarios like these 3. So we'll wrap it up for here for Chapter 7, for 7.3 and 7.4. Please let me know if you have any questions as we proceed. Have a good day.